Hi everyone, I'm back and it is a whole year later, actually a little over a year, and I decided that I was going to continue this. I've always wanted to continue it because I felt like it was unfinished business, and this is also one of my favorite things to teach because I understand it so well, and it's just, I don't know why I'm such a nerd, but I think it's really fun. So the feedback was that I sound like I'm in a blender in my last videos. I might have to remake them because of that. But, anyways, yeah, I just kind of got on with life, and it was more of a hobby thing. It was for a friend. It wasn't like, it was kind of as a joke, but I kind of really like it anyway. So that's just kind of like one of my intros things. But I always wanted to come back to it, especially because I use it to tell my friends, like to show my friends and make them hate me because they don't understand what I'm doing and why I'm making them endure the pain of watching this crap because they don't understand it. But it's fun for me, and also when people need it and can take it, it might help. So, you know, why not? So, yeah, it's been a year for sure. So, but the main thing is we're back. Who knows how long until the next one is, because this is only I finished step 1. So part 1 is glycolysis. So we have finished glycolysis. There's 3 parts. 3 more parts. There's 4 parts. So glycolysis. So let's get on with that. Let's just do that. So because I sounded like I was in a blender, I now have my AirPod in, so hopefully that you can hear me a little better. And I'm also filming on my phone and not my laptop. So I hope you guys can see the board well. So maybe I should take off I don't know. Okay. Anyways, well, what we left off on is we had this molecule right here. And we had 2 of them because if you remember, you would have had to watch the first part to understand anything that's happening here. So there's 2 of them because it was a big split. That was basically rearranging, big split. And we didn't get anything from it quite yet. This part, steps 6 through 10, they are basically, we are getting some parts out of it, and we're left with some leftovers that are going to go through more to get more. And what we want is ATP. ATP is energy. And so every ounce of energy that we get, it's kind of measured in its own little area. So it's just ATP. So we use 2 ATPs to go through glycolysis because you use energy to go through it and you get 4 out of it. And so I'm going to go through that process. So everything here, you see around the boards, there's ×2 everywhere. That's because there's 2 going, so you remember there's 2 exactly the same, and then they're going through the process at the same time, you know? So we're just going to focus on 1, but just keep in mind that there are 2 so that when you get the end results, you're getting the right amount of ATP. Okay, step 6. So this is glyceraldehyde 3-phosphate, which, so this is the same as what we had before. And what we're going to do is we're going to use an enzyme called glyceraldehyde 3-phosphate dehydrogenase. And that is going to strip it of a couple things. So our NADH, which is just something that exists, it's more of like a given in your, it's just kind of like a given. You put in that and you get NADH, which is going to help us later and turn in, it's going to basically cash in to get more ATP at the end. So at a later stage in a different part of respiration. So we get 2 of them and we get 2 hydrogen atoms. So cool. I made a little chart over here. So this is what we get out of it. So We got 2 NADHs from that because there's 2 going through. And then we got also 2 hydrogen atoms, which doesn't really matter that much, but I just put them there for reference. And then we get some, we just get some products. They turn into NADH and H+. So we get something that's going to be like a token in the end that cashes in for, my biology teacher told me, like, she's like, oh, it's like you're going to a casino and you have like a token. So that's a good way to remember it. So, this is bisphosphoglycerate, which is step 7, okay? And we're going to use phosphoglycerate kinase as the enzyme here. So what's going to happen is there's a little bit more rearranging. So we take the H, well, the H is already out, right? Because of this changes to an H. And then so the bonds kind of change in it. And what happens is we actually get, at this step, we get to ATP. So the ADP turns into ATP. So, but that's kind of what's happening. So you get products. So then we have the -2 because it takes 2 to go through all of glycolysis. And I didn't talk about it before because it wasn't important yet, because nobody would understand because we hadn't got to getting results back yet. So, -2, so that's what it takes to go through the glycolysis. That's 2 energies. That's the best way I'm going to say it. And then +4 at the end. But we have 2 right here. We have 2 right here. So we just got what we put in. So we're just back where we started. So now we're going to go on to here. This one is called phosphoglycerate, 3-phosphoglycerate. So then it's a little more just kind of rearranging. Now we just got the ATP, so we just kind of, we have another oxygen right over here. So it's not a double bond. Well, it's a double bond in a different place. And then we have, so that's going to be cool. And we're going to use the enzyme phosphoglycerate mutase. And some more rearranging, and this one is so much fun because we change the OH to right here, and that's all we do. We literally just go move it down from that carbon to that carbon. So interesting, my favorite thing. I honestly, like, I don't know why anyone would want anything different, but now, because of that, we now have 2 phosphoglycerate and not 3. And then we use the enzyme enolase. And what we do is we get H2O from that. We get 2 of them. Okay, so we remove that. We remove the H2O. So the OH goes away and one of the hydrogens goes away. So we're left with this. And because of this, we are going to get 2 more ATP from that. So 2 more energies. Okay, we like energies. Okay, but now this one is phosphoenol pyruvate, or PEP for short. And we use the enzyme pyruvate kinase. And that step 10 is actually a little bit of reverse action. So you get this ATP, but then we put the hydrogen back. We put the water molecule back in. So it like takes it back. So in order for that to get ATP, you need to get rid of the hydrogen and the 2 hydrogens and the oxygen to get this. But then you're like, I want it back actually. So you take the water. That's why we don't have any products. We don't have any of the water because it gets back into the equation right now. And so then we get pyruvate. So we have 2 of them obviously, and they're going to go through all the other stages that I'm going to continue. But we have a different molecule now. So results in 2 pyruvate molecules. So this is pyruvate. I don't know if you can see very well because this is pyruvate. Okay, it's pretty cool. It's going to go through some more arranging, and it's going to get, we just keep picking it apart because we want all that. And this is a tiny sugar molecule. Everything you eat has sugar. It's not, like I said in the first video when I was introducing everything, sugar molecules is not like, oh, the sugar you eat. It's in Like, it's in everything. It's a single molecule of what you're eating. So it's not like, oh, this is sweet, then it's sugar. Not a gram of sugar. It's not that. It's the more natural type. Okay. So what we have, though, is we have 2 hydrogen atoms, which just kind of go and do their own thing because we don't really need them anymore. We have -2. We have to account for the -2, so I just keep putting it there instead of saying 2 because then it would be confusing. We have -2 to go through, and we got 4, okay? And then we got 2 NADH, which is our little tokens that we're saving for later. So that is part 2 of glycolysis, which is steps 6 through 10. This one happened a little bit faster because I kind of realized what I was doing wrong was making too many videos and not making much sense. So, so that's that. I hope that it helped if you're needing help in this subject, or I slightly entertained you, or if you're my friend and I forced you to watch it. Anyways, I will try to make another video at some point. I definitely will finish this. I'm not gonna it's gonna take a while, maybe take another year or so, but someday the whole thing will be finished. Also, just, you know, an update. I'm still at Montana State University. I'm establishing residency, so I'm only taking 1 class and I work full time. So that's kind of fun. And so I'm not doing much chemistry in my class since I'm just taking a math course. So hopefully I can do this again because it kind of reminds me why I love what I love and not because I'm going to school and just going to math every day and hating it. Because I love chemistry. So another thing is, I don't know if I mentioned this in my last videos, but I have never taken organic chemistry. I took AP chemistry and we kind of went over some of this. I went into more depth because I'm a nerd and I wanted to, like, on my own. Nobody forced me to do this. I've never taken organic chemistry. I taught myself organic chemistry, sort of. Not completely. Like, I didn't teach myself everything in organic, but I kind of taught myself the basics because I have no life. I do have a life. It's just a lot of science, and I enjoy science, which is why I kind of feel like biochemistry is the right place for me. Anyways, we'll see you next time.